So we are now in the Module 11 of Bridging SRWE course. So, Module 11 is all about the switch security configuration. So we have the module objective is to configure switch security to mitigate LAN attacks. We also have the topics covered. So in this module we have the implement port security to mitigate MAC address table attacks. So we have the mitigate VLAN attacks. We have to explain how to configure DTP and native VLAN to mitigate VLAN attacks. Mitigate DHCP attacks. Configure DHCP snooping to mitigate DHCP attacks. So mitigate ARP attacks to configure ARP inspection, and mitigate STP attacks. We also have to explain how to configure port fast and BPDU guard to mitigate STP attacks. So the first topic in the switch security configuration is the implement port security. So within this topic we have the secure unused ports, mitigate MAC address table attacks, enable port security, limit and learn MAC addresses, port security aging, security violation mode descriptions, and ports in error disabled state, and then verify port security. So first we need to discuss the secure unused ports. So layer 2 devices are considered to be the weakest link in the company's security infrastructure. So layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common layer 2 solutions. So all switch ports should be secured before the switch is deployed for production use. So a simple method that many administrators use to help secure the network from authorized access is to disable all unused ports on a switch. So for example, we have the Cisco switch, and we only use the first 3 ports. So the first Ethernet /3 /0 to /3, and it is a good practice to disable the remaining 21 ports. So how can we do that? We just issue the shutdown command. So in the global configuration mode, we enter the interface range fast Ethernets /08 to /24. So we issue this command to configure the range of interfaces, and then we need to enter the shutdown command to disable all of these ports. Next is the mitigate MAC address table attacks. So the simple and most effective method to prevent MAC address table overflow attack is to enable port security. So port security limits the number of valid MAC addresses allowed on a port. So by limiting the number of permitted MAC address on a port to 1, port security can be used to control unauthorized access to the network. So we have here the example. So the switch only allowed this PC with the MAC address of all ones. So we have here, but these attackers here, so they are not allowed because it is not in the allowed MAC addresses of the switch. So next is the enable port security. So for us to enable the port security, we need to type in the switch port security, and the show port security interface. It's also a command that displays the current port security settings in an interface. So for us to enable the switch port security or the port security, we need to type in the interface of the port, and then we need to type in the switch port security. But as you can see, this command is rejected because for us to enable the port security, it must be configured in a manually configured access ports. So we need to type in the switch port mode access first, then the switch port security. Also, like I said, we have the command show port security interface, so it can be typed So it must be typed in the privileged exec mode. So as you can see, we have here the current port security and port status violation mode. So it is the current port security settings. Next is after enabling the port security, we can also configure other port security specifics like aging, MAC address, maximum, and violation. Next is to limit and learn MAC addresses. So to set the maximum number of MAC addresses allowed on a port, we use the command switch port security maximum and its value. So for example, here we have the need to go to the interface port, then type in switch port security maximum. So in this example, we have 8192 maximum addresses. So they only need to enter a value between these numbers. So for example, switch port security maximum 4. Okay. Next is the switch can be configured to learn about MAC addresses on a secure port in one of 3 ways. So first, the manually configured. So the network administrator statically configures, or the manually configures the MAC addresses to be secured. Then second is the dynamically learned, so it's automatically. Then 3 is the dynamically learned sticky. So we have the example here. So they go to interface, the first interface, then switch port mode access, enable port security, and then they enter the maximum value for the MAC addresses, so which is 4. Then it also configures, manually configure the MAC addresses. So for example, we have here the MAC address, and also they issue the show commands like show port security interface and the show port security address to verify the configuration. Next is the port security aging. And then we use aging to remove secure MAC addresses on a secure port without manually deleting the existing security MAC addresses. So there are 2 types of aging that are supported per port. We have the absolute and the inactivity. So the absolute is the secure addresses on the port are deleted after the specified aging time. So we have also the inactivity. The secure addresses on the port are deleted only if they are inactive for the specified aging time. So here the example of configuration. So for the interface fast Ethernet 0/1, we entered the command switch port security aging, and then time, then for the 10 minutes. So first of all, we have here the parameters of, for the command. We have the static, so we can enter command switch port security aging static. So enable aging for statically configured secure address on this port. So we can also have aging time, so it specifies the aging time for this port. So the range is 0 to 1440 minutes. We also have the type, absolute and inactivity. So it just specifies what type of aging on the port. Okay, and then the command switch port security aging type activity. So in this configuration, it just configures what time or how long for the aging, and then the type of the aging. Then we can also verify the configuration by entering this command, show port security interface fast Ethernet 0/1. Next is the security violation mode descriptions. So for port security violation modes, if the MAC address of the device attached to the port differs from the list of secure devices, so then a port violation occurs. By default, the port enters by error disabled state. So to set the port security violation mode, use the following commands. So switch port security violation, then you can choose to protect or restrict or shut down. So here we have the port security violation modes, descriptions. So for protect, restrict, and then shut down. So all of this discards offending traffic. And then for the restrict and shut down, so it sends a syslog message. So after disabling, it sends a syslog message. So it also increases for these two, the violation counter. And then, but for shutdown ports, it's also violation mode shutdown. So it's the one that shuts down port. Next to be discussed is the last topics for implementing port security. So last points. So ports in error disabled state and the verify port security. So ports in the error disabled state. So when a port is shut down and placed in an error disabled state, no traffic is sent or received on that port. A series of port security related messages display on the console. So we have here the sample message. So we have here, I think it's a date. So error disabled, secure violation error detected on this port. Then putting this fast Ethernet port in error disabled state. Then to enable the disabled interface port, we need to first use the shutdown command, then the no shutdown command. Second is the verify port security. So verify port security is like show configurations. So for us to show port security for all interfaces, so we enter show port security. So those shows displays the secure ports of fast Ethernet /24, then security action, security violation to count. Okay. Next is the port security for a specific interface. So this is for all the interface. Now this is for specific interface. For this example, we use the port /82, so Ethernet. And then you can also verify the learned MAC addresses. So we need to use this command, the show run, then begin interface, and then the port to fast Ethernet. And the last is to verify secure MAC addresses. So we need to use this command, the show port security address. So you can see the secure MAC address table, the VLAN, so their MAC addresses, their type, if it's a dynamic or sticky, then all the ports. So for the last, we will be doing this implement port security. So for syntax checker, so we are currently logged into S1. Configure fast Ethernet 0/5 for port security by using the following requirements. So use the interface name fast Ethernet 0/5 to enter interface configuration mode. So first we need to type in interface FA 0/5. Next is we need to enable the port for access mode. So switch port mode access. Next, to enable we need to enable port security. So switch port security. Next is we need to set the maximum number of MAC address to 3. So switch port security maximum 3. Next is we need to statically configure the MAC address. So with this MAC address, switch port security, type in MAC address, then this MAC address. Next is configure the port to dynamically learn additional MAC addresses and dynamically add them to the running configuration. So we just need to copy this and type in sticky. So configure, return to the privilege except mode. So enter the command to verify port security for all interfaces. So show port security, then enter the command to verify port security and fast Ethernet 5. So show port security, so interface FA0/5. Next is enter the command that will display all the addresses to verify that the manually configured and dynamically learned back addresses are in the running configuration. So just type in show port security address. And now you have successfully configured and verified port security for the interface. Now we are here to the mitigation of VLAN attacks. So we have the steps to mitigate VLAN hopping attacks. So use the following steps to mitigate VLAN hopping attacks. So first, we need to disable auto-trunking negotiations on non-trunking ports by using this command, the switch port mode access. Next, to disable unused ports and put them in unused VLAN. Step 3 is manually enable the trunk link by using this command, switch port mode trunk. So step 4 is to disable auto-trunking negotiation on trunking ports by using this command, switch port non-negotiate command. And the step 5 is to set the VLAN other than VLAN 1 by using switch port trunk native VLAN and the VLAN number. So we also have here an example. So the fast Ethernet ports 1 to 16 are active access points, 17 to 20 are not currently in use, so it's unused. And then 21 to 24 are the trunk ports. So we have here the example here. So 1 to 6 Ethernet, fast Ethernet 1 to 16 are the used ports. So we need to disable the DTP, and by manually making them as access ports. So 7 to 20 are unused ports. So we need to disable DTP and assign them to unused VLAN. So for this example, we have the VLAN 1000. So it's for the interface 21 to 24. They enable them as the trunks, and then disable the DTP, and then so they change the default VLAN 1 to VLAN 999. So now we will be doing this syntax checker for mitigation of VLAN hopping attacks. So you are currently logged into S1. The port status of the ports are as follows. So 1 to 4 are used for trunking with other switches, 5 to 10 are unused, 11 to 24 are active ports currently in use. So first, we need to use range 1 to 4 to enter interface configuration mode for the trunks. So these ports are used for trunking with other switches. So just hit interface range FA0/1 to 0/4. So configure the interfaces as non-negotiating trunks assigned to default VLAN 99. So first we need to type in switch port mode trunk, and then non-negotiate. So switch port, then non-negotiate. Then we need to assign this to default VLAN 99. So switch port native VLAN. Start trunk native VLAN 299. Next is we need to enter in this range interface FA0/5 to 10. Oops, I forgot to include the range here. Configure the unused port as access ports. Assign them to VLAN 86 and shut down ports. So switch port mode access. Okay, and then we need to assign this. So switch port, so access VLAN 86, and then we need to shut down. Okay, so we use the 11 to 24 to enter interface mode for active ports, and then configure them to prevent trunking. So we need to interface, let's say /11 to 24. Oops, I always forgot the range. And then switch port, mode access. That's it. So next is the mitigation of DHCP attacks. So it is also the third topic for switch security configuration. We have here the DHCP snooping. So we will discuss quick discussion of what is DHCP snooping is, and steps to implement DHCP snooping. So DHCP snooping does not rely on source MAC addresses. Instead, DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. So it then filters DHCP messages and rate limits DHCP traffic from untrusted sources. So trusted interfaces are typically trunk links and ports directly connected to the legitimate DHCP server. So in this example here, we have here the trusted port and the untrusted port here. Because it is trusted because it is one of the trunk links. So it is inside the firewall. So outside the network is the untrusted port. Okay. Now we also have the steps to implement DHCP snooping. So let's put here. So use the following steps to enable DHCP snooping. So we need to enable DHCP snooping by using the IP DHCP snooping global configuration command. So we have here an example. IP DHCP snooping. The untrusted ports use the IP DHCP snooping trust interface configuration command. So on the trusted port only, and then limit the number of DHCP's discover messages that can be received per second on untrusted ports by using IP DHCP snooping limit rate interface configuration command. So we are limiting the messages here in this command IP DHCP snooping limit rate, and then where are we? Enable DHCP snooping by VLAN or by range of VLAN by using the IP DHCP snooping VLAN global configuration. So we also have the example here prepared. So the following is an example of how to configure DHCP snooping on switch 1. So this is also the example here. So notice how DHCP snooping is first enabled here in this part, and then the upstream interface to the DHCP service is explicitly trusted. So they specifically pick the interface port is 0/1. Then the next range of fast Ethernet ports from 5 to 24 are untrusted by default. So we need to limit it. So by entering IP DHCP snooping limit rate 6. Okay, and finally, DHCP snooping is enabled on these VLANs 5, 10, 50. Okay. So now we will be doing this syntax checker, mitigate DHCP attacks. So you are currently logged into S1, enable DHCP snooping globally for the switch. So I think this is based for this topology. So first we need to enable DHCP snooping. So IP DHCP snooping. So enter interface configuration mode for these ports, trust the interfaces, and return to global configuration mode. So IP DHCP ups interface range, trust the interfaces, trust, and then return to global. So enter interface mode 4. This ports limit the DHCP messages to no more than 10 per second. Then we will return to global configuration mode. So interface range, and then this ports, send IP DHCP snooping, then limit rate to 10 per second. Exit. Enable DHCP snooping for VLAN is 10, 20, 30 to 49. So IP VLAN, just need to copy these ports and then enter the command to verify DHCP snooping. So just show IP DHCP snooping. Next is we need to enter the command to verify the current DHCP bindings logged by DHCP snooping. So just need to copy this and add bindings. You have successfully configured and verified DHCP snooping for this switch. So now we're in the mitigate ARP attacks. So this includes the dynamic ARP inspection, the implementation guidelines, and die configuration example. So the die or the dynamic ARP inspection requires DHCP snooping. So we discussed this earlier, and helps prevent ARP attacks by not relaying invalid or gratuitous ARP replies out to other ports in the same VLAN. So it also we can prevent it by intercepting all ARP requests and ARP replies on untrusted ports. So verifying each intercepted packet for a valid IP to MAC binding. So dropping and logging ARP replies coming from invalid to prevent ARP poisoning. So prevention is so it helps prevent ARP attacks by also error disabling the interface if the configured die number of ARP packets is exceeded. Now for the implementation guidelines. So I have here, so to mitigate the chance of ARP spoofing and ARP poisoning, so we must follow this die implementation guidelines. So we need to enable first the DHCP snooping globally. So enable DHCP snooping on selected VLANs. So enable die on selecting VLANs and configure trusted interfaces for DHCP snooping and ARP inspection. Next is for the die configuration example. So I have here the die example. So we need to enable the IP DHCP snooping, then the IP DHCP snooping VLAN. So as mentioned earlier, so enable DHCP snooping on selected VLANs, and also the die here, and also configure the trusted ports. Okay, we also have here, we can also use die to inspect the address. So for example, we need to validate this address, the destination MAC address, the IP address, and then the source MAC address. And then we have here the example. So just like the DHCP snooping, there is also a trusted port and untrusted port. Okay. Now we will be doing this syntax checker mitigate ARP attacks. So you are now currently logged into S1. So enable DHCP snooping globally for the switch. So we need to type in IP DHCP snooping. So enter interface configuration mode 4, G0/1 to 2, trust the interfaces for both DHCP snooping and die, and then return to global configuration mode. So we need to enter to this interfaces. Next is trust the interfaces. So IP DHCP snooping trust. Now we need to trust for the die. ARP inspection, trust. Next is to return. Enable DHCP snooping and die for VLANs 10, 20, 30 to 49. So IP DHCP snooping, VLAN, and then 10, 20. Also for the die, inspection, then this VLAN. We have successfully configured die for the switch. Now we're in the last topic for the switch security configuration, which is to mitigate STP attacks. So this includes the port fast and BPDU guard, configure port fast, and configure BPDU guard. So recall that network attackers can manipulate the spanning tree protocol to conduct an attack by spoofing the root bridge and changing the topology of the network. So it is a STP attack. To mitigate spanning tree protocol manipulation attacks, use port fast and BPDU guard. So for us to enable to mitigate the STP attack, so we use port fast and the BPDU guard. So for the port fast, the port fast immediately brings an interface configured as an access or trunk port to the forwarding state from a blocking state, so bypassing the listening and learning states. So while the BPDU guard immediately disables a port that receives a BPDU. So here, this is the example. So in this topology, these access ports here must be configured with BPDU guard and port fast. So configure port fast. So this is the sample configuration. So for the interface configuration mode, so we enter the switch port mode access and the spanning tree port fast. So port fast should be enabled in ports connecting a single host. So we also have the spanning tree port fast default in the configuration mode. So this command enables port fast by default on all interfaces. So it's a default. And then to configure BPDU guard, we have here a sample configuration. So like earlier, we have the interface configuration mode. So we enter spanning tree BPDU guard enable. So we can also use the spanning tree port fast BPDU guard default for to enable these BPDU guard for all interfaces. Now we will be doing this syntax checker, mitigate STP attacks. So we are currently logged into S1. So complete the following steps to implement port fast and BPDU guard on all access ports. So first we need to enter into the interface configuration mode for fast Ethernet 0/1 to 24. So interface range, and then this interfaces. Then configure the ports for access mode. So we just need to type in switch port mode access. Next, we return to global configuration mode. Then enable port fast by default for all access ports. So spanning tree port fast default. Next is enable BPDU guard by default for all access ports. We just need to copy this, then type in BPDU guard. Okay, verify the port fast and BPDU guard is enabled by default by viewing STP summary information. So we just need spanning tree summary. So spanning tree summary. We have successfully configured and verified port fast and BPDU guard for the switch.